Partial fractions.
So we just find the LCM. Then x plus 1 goes into this LCM, x plus 1. So assuming x plus 1 cancels x plus 1, we are left with x minus 1. Then we multiply by the numerator. We end up getting x minus 1 plus, now x minus 1 cancelling x minus 1 will leave us with x plus 1. So x plus 1 times the numerator. Now, partial fractions are in 4 distinct forms. When the denominator is a linear factor, when the denominator is a quadratic factor, a repeated factor, and then an improper fraction. Let's begin with when the denominator is a linear factor.
It's question time!
Solving partial fractions, what we do is that we are separating the denominators and then we consider the numerators as constants. Now that's what I mean. This is equivalent to, now we want to separate these two denominators. So we have x minus 2 as 1, then x plus 3 as 1. Then we consider the numerators as constant, but in this case, we don't know the constant number. So let's use alphabets or variables to represent them. Now, for the alphabet, it can be, you can choose any of them, but I would prefer A and then B. Okay, and let's not forget they are divided. So we've separated them. And whenever we separate, we add. So always add them. So what would be the LCM for this? In this case, our LCM will be x minus 2 and then x plus 3, which are the denominators. If x minus 2 cancels x minus 2, what is left? X plus 3. Then we multiply with the numerator. So A multiplying x plus 3. Then our addition sign plus. Now, if x plus 3 cancels x plus 3, we are left with x minus 2. So we multiply with the numerator b. So b multiplying x minus 2. Let's not forget that this side is equivalent to this side, so let's rewrite this. Realize that the denominators are the same, and since the denominators are the same, we can ignore them. So let's write the numerators. We have now this, we have an identity given here, and with this identity, I've already done a video on how to solve identities. So I prefer the cover-up method. So let's use that. I want a to be equal to 0. So when x is equal to minus 3, I know that a will be equal to 0. So let's put minus 3 in the equation. We have 3 minus 2 minus 3. And since now this equivalent sign or identity sign will change it to an equal to sign when we are putting x to be equal to a certain number. So this will be an equal to sign. Now minus 3 here, so we have a minus 3 plus 3 plus b minus 3 minus 2. Now let's simplify. It's now minus 9 on 5. If I put 2 here, then b will be equal to 0. So when x is now equal to 2, the entire equation will be 3 minus 2 times 2. It's equivalent to a 2 plus 3 plus b 2 minus 2. Now I have 3. A is equal to minus 1 on 5. To rewrite them in the form of a fraction, how we represent it in the form of a fraction. So we had, after getting a value for a and then b, then you write it in the form of a fraction. Now, if your answers are fraction, the denominator will come and join the denominator here, just like this. Then, if there is a sign in front of them as negative, you bring them. Now, if you don't want any trouble, you can remove this positive sign and just use a negative sign here. So, the first thing we are doing is we are separating the denominator since they are linear. Then we consider the numerators as constant, but in this case, we don't know the constant term. So let's use alphabet to represent them. And I said that don't forget they are always adding an identity sign. So let's find our LCM. So our LCM is x minus 1 and then x plus 1. Now, this cancels. We have a, then x plus 1, plus b, then x minus 1. Since the denominators are the same, let's write the numerators. Now b is equal to 1. Of a, then a is also 1. Unlike the first one, there were two linear denominators, but this one is just one quadratic denominator. But if we are to simplify this denominator, we are going to get two linear denominators. In algebra, if we have 1 minus x squared, this is difference of 2 squared, because this 1 can also be written as 1 squared. And we are finding the difference of two particular squared numbers, 1 minus x and then 1 plus x. So in this case, we want to separate the denominator into, so we have 1 minus x here and 1 plus x. So when x is equal to minus 1, is equal to 3 on 2. We have the values of a and b. Let's write them as fractions. Now identical to a. A is 3 on 2. Now the denominator for a is 1 minus x plus b. B is 7 on 2, so 7 on 2. Then denominator for b is 1 plus x. The denominator is a quadratic equation. And if we have to solve this quadratic equation, we are going to get two linear factors. Two factors, x minus 2 and then x plus 1. You can go and watch a video on quadratic equations to better understand how I got this. Okay, now we have our separated linear factors. So let's go and rewrite everything. We have 2x minus 9 over x squared minus x minus 2. It's now equivalent to, we want to separate the denominator. So we have x minus 2 and x plus 1. Now, I'm still using a and b. Then let's add them. X minus 2, x plus 1. Now, so when x is equal to minus 1, so b is equal to 11 on 3. Now let's find a, but x is equal to 2. Equal to minus 5 on 3. Let's write it in the form of a fraction.